Hi everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 2322, minimum score after removals on a tree. You can pause the screen and read the problem statement. I'll directly explain you on the screen. These are the examples. This is the first example. This is the second example, and these are the constraints. Okay. Okay. So yes, so let us focus on this particular screen now. So we have given a tree, and this tree is basically undirected. So just focus right over here. This is the tree that has been given to us. Okay, in input. So these edges are not directed. All these edges are undirected. Okay, so tree is undirected tree, and in total, n nodes are there. Here, 5 nodes are there. 1, 2, 3, 4, 5, and the nodes start from 0 all the way to n minus 1. Okay, so in total 5 nodes we have. The starting nodes start from 0 all the way to n minus 1. The last node will be having n minus 1 value. So total 5 nodes we have, last node is having 4 as a value. Okay, so yes, this is something what it is already provided, and also it is given that these all the individual nodes that we have, they have some weight as well or some value. Okay, for 2 the value is basically 5, for 1 the value is 5. Okay, for 3 the value is 4, for 0 the value is 1, for 4 the value is 11. Okay, these values are also provided with us. So now what we have to do is we have to simply split this particular tree in 3 different components. So currently there is only single component that we have. So what we have to do is we have to split this particular tree in 3 different components. So we have in number of choices, right? Look, it is not necessary that we have to split any particular edges only. We can remove any 2 edges. That way we will definitely going to get 3 different components. Let us say that for this particular one, we remove this particular edge and remove this particular edge. Okay, so this individual is going to be one particular component, this is another component, this is another component. So in total 3 different components we have. So this is the first, second and third. Okay, this way I just removed this particular edge, this particular edge, these 2 components I have, these 2 edges I have removed, and that way we got 3 different components. Now once we got these 3 different components, what we have to do is we have to simply perform a XOR operation of these values. Okay, so for this particular individual component, the XOR operation is like 5 XOR 4 XOR 11. Okay, that's how we perform the XOR operation. So the value is basically 10. 10 is the value that we are getting it. Okay, second component, here value is only 1, so individual elements XOR is going to be same one. For third component, value is 5, so XOR operation will be 5. 5 is the answer that we are getting it. Okay, the idea is pretty much clear here. So now what we have to do is, out of these 3 different values that we are getting it after performing this XOR operation, so we have to pick the maximum value and the minimum value. So from this particular 10, 1, 5, the maximum value is 10, the minimum value is 1. Okay, the minimum value is 1, sorry. Okay, so now what we have to do is this max minus min is something what we have to perform, and the answer that we are getting it here, 9 is the answer that we are getting it. This is something what we have to return. So this answer that we are getting it, so we have n number of possibilities, right? Like it is not guaranteed that this particular splitting is basically giving us the best answer. So we may can split this one, so this way, like this is individual component, this is, and this is like 3 different components. Here also we are getting it. That way also, like we have to perform XOR operation between 5, 1, 5, then individual 4 and the individual element. Then once we get this, like we have to get the maximum value out of these 3, whatever the XOR option we have done, and minimum value, and we have to subtract them. So out of that also, if we get minimum value, then obviously that is going to be the answer. So we have to get this minimum answer, and this is something what we have to print into the output. So let us suppose that this same tree I have split it in this particular fashion. So I have this 3 and 4 one component, so I have split right over here. Then 1 and 0 is another component, and this is also, these 2 edges I have removed. So this is basically formed like this way. Okay, so 4 and 11 XOR is basically 15, 5 and 1 XOR is basically 4, and 5 individual XOR is basically 5. So out of this 15, 4, 5, the maximum is 15, the minimum is 4. So 15 minus 4 is basically answer. 11 is the answer that we are getting it. This way also we are getting an answer, but this value, whatever the 11 answer that we are getting it, it is actually greater than this 9. So best answer that we can achieve is this one. Okay, this way if we split it, we are getting the best answer. Okay, so this best answer is something what we have to print into the output. Okay, the question is pretty much clear now. So let us focus on how we can solve it. Okay, what we will do is we will simple use a DFS algorithm right over here to make the cuts. Okay, the first cut, that wherever we are putting it, again we will try to use the another DFS to put another cut in different areas. Okay, question is pretty much straightforward. Once you get this idea what I'm trying to say, you will easily solve this question by yourselves only. Okay, so let me try to explain you like how we can apply this DFS technique right over here to make sure that we are putting 2 cuts and we are collecting their XOR values as well. Okay, so just focus right over here with this particular example now. So this is like the individual whatever these nodes that are there, right? So their values are basically provided in this way, or their weights. Okay, in an array these values are basically provided. So I represented it, this particular tree, in this fashion. Okay, so this is the tree that has been given, and their weights are also provided with us, right? So now we will use a simple DFS technique for this particular one. Okay, how it will works, let us focus right over here. So once we call here a DFS, okay, we will start from the zeroth node, right? So we will start from the zeroth node. We can pick any particular node. There is no restriction on that, which node we are picking, but we will start from the zeroth node. Okay. So when we call the DFS, the call goes to these adjacent nodes. So first is like the call reaches, let us suppose, at this particular node. Okay. So from here, the call may go right over here. It can pick any of there. Okay, whichever is available at the top in the adjacent list, it will go right over there. So from 0 we reach to 1, from 1 we reach to 3. Okay, now we are at 3. So from 3, we don't have any adjacent nodes where we can go. This one is actually from where we came. Okay, so we have to keep track of like from where we actually came so far. That is also we have to keep track. So we will maintain another parent variable which will basically tells like from which particular node we came right over here. So that I don't make recall right over here. From 3, the adjacent node is basically 1, right? Again. So I don't want to revisit the same node from where I came back. Okay, so we will maintain a simple parent variable which will tells us like if we came from the same previous parent node, we will not revisit that particular node. So from 3 we don't have any further nodes where we can go. Okay, so this is the last node. What we will do is simply we will put a cut right over here. Okay, the first cut that we are putting is right over here. Okay, so 3 individual is going to be a component. So 3 individual is going to be a component. Once we put a cut right over here at this place, the other options are, we have these all the places we can put another cut. Okay, these are all the other options that we are available with. Okay, this is the first cut that we have done. Now second cut may be right over here. So this is the first cut, and this can be, I mean, this is the one way we can have. The another cut is like this is the first cut, second cut could be this one. So this is like another way possible we have. Next is like if we put right over here cut, so this is one way. This way also we can have the option. Last is like right over here we put a cut. So this all the tree is one part, and this is like individual part. So this way also we can get the answer. So we have now, the moment we reach to the last node, we put right over there a cut, correct? So this is individual component. Then we have all these operations, like here also we can put a cut, here also we can put a cut, and we can generate the answer. Here also we can do, here also we can do. So we have these all the other options left. So obviously we have to try out all the different possibilities. Okay, so it is not like I have put one cut right over here and second but I'll try to put it and I'll try to generate the answers. No, it is not like that. So if I put cut right over here, I have to try out all the different possibilities. Like I will try to make sure another cut, I'll put it in all the different edges available right over there and try to generate the answer. Okay, so that is the basic idea. So once in the first DFS we reach to the last node right over here. Okay, so from here I don't have any further options to go. So I'll put the cut right over there, and I'll start reverse DFS from this particular parent node. Okay, I'll start calling reverse DFS from this particular parent node. Okay, so now I got the answer right over here. What is the XOR value at this particular location? Okay, how we can get it? So first thing what we will do is we will try to collect the entire value XOR. So all the nodes XOR is something what we will create right over here. So I'll name it as a total XOR. Okay, total XOR is something what I'll name right over here. So this total XOR looks like from 0 I'll start 0. For 0 the value is 4, for 1 the value is 5, for 2 it is 3, for 3 it is 5, for 4 it is 1, and for 5 it is 7. Okay, total XOR is something what we have collected. We pre-compute this particular value initially. Okay, this way we will get to know like how, all the different cuts XOR operations. Okay, now once if I put right over here at this particular location a cut. Okay, if we put a cut right over here, so this component individual is going to be there. So this particular individual component value is basically 5. Okay, single component, if it is there at last, it is going to be a single component, right? When we reach to the last node, it is going to be a single component, so its value is going to be 5. Okay, so cut one value. Okay, cut one XOR where we are putting the cut, so its value is basically 5. The individual elements XOR value is basically same one. Okay, since we have put the cut right over here, so it is an individual element, so its value is basically 5. So cut one XOR is basically 5. Okay, that is something what we have done. Now what we will do is we will start from here again. We will, so right over here we reach, so it's parent node, whatever the parent node we have for this particular tree. Okay, from where we came, okay, we will go right over there for that particular node, and from here we will keep on calling the DFS again. So this way, the idea is, again from here when I start calling, I don't want to go and revisit this previous node from where we came. Okay, because this one was broken down right over here. Okay, this got broken down, so from one I'll keep on calling to the adjacent nodes. So for one, the adjacent node is 0 and 4. I don't want to go in this particular direction because there I have cut. Okay, so we will maintain a parent child relation. That way we will easily get to know like from where we came and where we want to go. Okay, so from 3 we came, so I don't want to go again for the 3. Okay, from 1 I do have these addition nodes like 0 and 4. So either of the way we can go. From 1, let us suppose 4 is something what we have explored first. Okay, from 1 we have explored, 4 is something what we have explored. Now from 4 we don't have any options further going ahead. Okay, this was the last element that we have right over here. Okay, and here I cannot go back because from there only we came right over here, right? So that is something what the parent node is something what we have to make sure tracking out all the way at all the places. Okay, because from 4 again we have this one as an adjacent node, but I don't want to go right there. Okay, it will be in a loop, then it will keep on doing the same operation. Like from 1 we will be going at the 4, and from 4 again we will go back to the 1. Okay, so we have to make sure that we are tracking out what was the parent node for this particular node. So for 4, the 1 is the parent node, so we are not going back right over there. Now 4 is the last value that we have right over here. Okay, so from 4 we don't have any further nodes. So what we will do is, here we will put the first cut. Next cut that we are trying to put right over here is, this is the next cut we are doing. So here we will put the next cut. Okay, so now once we put this next cut right over here, what happens, it will basically tell us, right? So this particular individual component. Okay, because here now it is an individual component. So this was individual component, its cut was basically 5 because it was an individual element. Now 4 is actually another individual element. Here we are putting the second cut. So second cut XOR is basically, because it is an individual element, so whatever the value that is there for 4, the value is basically 1. Here if you notice right over here in this nums array, the value was 1. So XOR of single individual element is going to be same. Okay, so XOR of this one is basically same. Okay, so what we have done, we have put first cut right over here, second cut right over here. So this is one element, this is another element. Now this entire is another separate part. Okay, so we got cut off 1, we got cut off 2. Now to get this entire values cut, like what is the XOR value of this entire right, if we want to get that, what we will do is, we have pre-computed this total XOR. Okay, we have previously computed this total XOR. What we will do is, to get this left out elements XOR, what we will do, we simply do this total XOR. Again, this with this total XOR, we will do again this. Sorry, let me change this color. So I'll pick this one. So this total XOR. Again, this total XOR, when we do this cut off, cut one XOR. Again, we perform the XOR operation with this cut two XOR. So this way what we get is like total XOR. Basically this was the total XOR. This cut 1 was 5 and this cut 2 was 1. Okay, when we perform the XOR operation, what happens, this 5 individual element, so this one property you should already have known. Okay, when we perform a XOR operation between the same elements like 5 XOR 5, what happens, the answer is basically 0. 0 is the answer that we get it. Okay, how it happens is like XOR between like for 5, the value basically how it basically represents 1 0 1. For again for second XOR, it is like how, this is how it basically represents. At any point in time, if this one, that is like set bits, are basically in even counts. Okay, here the counts are even, like 1 1, so the value is basically 0. For 0 it is 0 anyway. For even counts it is again 0, so this value is basically 0. So at any point in time, XOR operation between the same element is basically cancelled out and it becomes 0. So when we try to perform the XOR operation between this total XOR, cut 1 XOR, cut 2 XOR, what happens, this 5 basically gets cancelled right over here, this 1 basically gets cancelled out right over here. So left out elements are like 4 XOR 3 XOR 5 XOR 7. These are the left out elements, correct? And this is like a component that is available, right? So these are all the values that are available basically right over here. Just try to focus and just compare these values. These are the values that are available, right? From this total XOR, what we have done, this 1 is basically we cancelled out, 1 is basically cancelled out, 5 is basically we cancelled out. So left out elements are XOR of this value. Okay, I guess the idea is pretty much clear now. So this way we got cut 3 XOR also. So this particularly, this value that is basically here is nothing but cut 3. Okay, this is nothing but a cut 3. Okay, this is cut 3. So now we got cut 1, cut 2, cut 3. This is the cut 3. So out of these values like 5, 1 and this particular value, which is the maximum one, that is something what we will try to figure out. Which is the minimum one, that is also we will try to figure out. And out of that maximum and minimum, we will try to generate the answer. Okay, this way we got one answer. This way we got one particular answer. Now next, like we have one possibility and that possibility we explored and that way we got the answer. So the idea is pretty much straightforward now. Again, going ahead, like we will try to put another cut in a different location. Okay, so this should be clear now what we have tried, what we are trying to do. So again, still the cut was right over here. The first cut was right over here at this location. We tried out right over here and we generated the answer. Okay, cut 3 was basically here. Let me name it as cut 3 is basically cut 3 of Zor is basically this cut 1. Okay, Zor cut 2. Zor total. Okay, whatever these values we basically get, out of that we will going to definitely get this cut 3. Okay, this way we done with one possibility. Now second possibility is again while going right over here. So once it is done, okay, once 4 is basically explode, the call basically go right over here. Again the call right over here, it basically goes. Again we are still trying to explore this arson values for this one arson value explode, and we tried generating all the answers from there. Okay, this was only one cut, we can put it right over here, and that is something what we have explored, and that way we achieved the answer. Okay, from here now again the call goes right over here. For one, the arson node is now next is 0. Okay, we are just trying to explore the what are the arson nodes for this one, because for 3 the parent was 1. For parent only we are trying to generate the answers. Okay, for 1 we explored this particular path and we tried getting the answer. Okay, that way we got one answer as well. Now next cut could be like in this particular area only we can have another cut. This explore, we have explored this particular word. Now for 1 the answer node is 0. For 0 again we will call a DFS. We don't want to go to its parent node, so we will keep on tracking what was the parent node for this 0. Okay, for 0 next is like 2, that is the addition node. For 2 next is like 5. Okay, the moment we reach to the 5 we don't have any further options to go, so we will simply put right over here another cut. We will put cut another cut right over here at this particular location. Okay, the moment we put this cut right over here, the cut to Zor is basically 7, because see its value is basically 5. Sorry, for 5 the value is basically 7. Okay, individual elements value is basically going to be the same. Okay, so cut 2 is basically now updated with 7. Cut 2 got updated with 7. Cut 3 is again going to be the same. So if we have this as an individual element and its cut value is basically 5, that is something what we have figured out. For this particular individual element the cut is basically 7. So again cut 1 Zor, cut 2 Zor, total when we do this 5 and 7 is something what it gets cancelled from this total, and remaining elements, whatever the remaining elements like 5 and 7, once it is cancelled, like 4, 3, 7, 1, these are the values that are there. Like this is the left out Zor, correct? This is the last one. So this is one cut, this is second cut, and this is the left out. So once we remove this 5 and 7 from this particular total sort, we will definitely going to get this answer for this particular one. That is clear. So this way we will get all the cut 1, cut 2, cut 3. Again from here we have to figure out which is the maximum one, which is the minimum one, and that way we will get the answer. Okay, now once this is done, okay, so DFS, since we are calling the DFS, it will again go back to the previous one. For 5, now for 5 it will the call go right over here. Okay, call goes right over here from 5 to 3. Okay, for this sorry, for this 2 from 5 it will go back to the 2. Okay, now for 2 we have already explored all the nodes and we cannot go back because it is a parent node. So for 2 is individual element now right over here. So while going back, while backtracking, what we will do is whatever the previous XOR value we have, here 7 was the value that we have, we will simply XOR with this true. Sorry, this particular 3. 7 XOR 3 is something what we will do while backtracking. Okay, while backtracking, we will simply keep this value, whatever this 7 XOR 3, that is something what we will get. That is something what we will update right over here at this location. Okay, so why we are doing that particular operation is like next cut could be right over here. So if we are putting a cut, we should get this answer. What is the value of this particular area? So XOR between 3 and 7, we should have it. Okay, we should have this particular value right over at this location. I don't want to go again and recompute its XOR values, whatever the elements that are there in this particular area. I don't want to do it. Okay, so while backtracking, whatever the XOR value so far we got it, like for individual single element XOR is basically 7. So 7 is something what we will return it, and whatever the XOR value right over, whatever the value that we have here, we will simply XOR with what was the previous value that we got it from here. Okay, so here 3 or 7 is basically we will be going to store right over here. For 2 we don't have any further options to explore. Okay, so again for 2 at this particular location we will put cut. Okay, the moment we explore all the adjacent nodes for any particular component in any component node. Okay, for 2 we tried exploring all the nodes, like 5 we explored, we don't have any further nodes going right over here, and 0 is actually its parent node, so I cannot go and try to explore the 0. Okay, so parent node we are not considering right over here. Okay, because it will be in a loop then again from 0 to 0. That is something what it basically happens, right? So next cut will be right over here. Okay, and I already said that here what we do is basically 3 or 7 is the value that we will store. Okay, while backtracking the idea is pretty much straightforward, like whatever the 7 value we have, we will simply XOR with this particular one. If we have further nodes right over here also, from here also, whatever the value that we are getting it, we will simply XOR with that particular one. Okay, this way we will keep on tracking the XOR values exactly at that particular node. So now here what we store is like 7 XOR 3, whatever the value that we are getting it, that is something what we will store right over here. From 2 we don't have any further nodes, so we will have this option to cut right over here, put a cut right over here. So simply what we do is we will put a cut right over here. So cut 2 is basically now cut cut 2 is basically now 3 or 7. 3 or 7 is the cut 2 that we have. So first cut is right over here. Still for the first cut only we are having these many options. Okay, second cut is right over here, third cut is right over here. Okay, this way 3 or 7 is something what we have at cut 2. While backtracking we stored this 7 value with this particular one, whatever the previous value that we have at this particular 2, that is something what we are trying to solve with from here, whatever the previous value that we got it. Okay, now 7 or 3 is what we have in this particular cut. So cut 2 is basically this one, cut 1 is basically this one, and uh, cut 3 is basically cut 1 or cut 2 or total. So this way what happens is like 5 3, these values basically get cancelled out. So 4 5 1, these are the left values in this particular area, right? 5 4 1. Okay, that way we will easily get the cut 3. Okay, so cut 1 we have, cut 2 we have, cut 3 we have. Again we have to pick the maximum out of this, the minimum out of this, and we will simply subtract it. Now while subtracting it, we have to just make sure that this particular value that we are getting, if it is actually minimum, we will simply update into the answer. So we will keep on tracking outside in a global, we can create another variable where we are keep on tracking like best answer that we are getting it, the minimum best answer that we are getting, that is what we will keep on tracking. Okay, once this is done, once this is done, for 2 we are done. Now for 5 initially we done, for 2 we initial, now we are done. Now call goes back to the 0 because from there only this call came, right? So the simple DFS technique is what I am applying. So call goes right over here at this 0th location. Okay, for 0 we already explored all the nodes. Okay, now I'll simply remove this one. For 0 we explored all the nodes that are possible. From 0 I cannot go back to this one. Okay, I mean I cannot explore this particular node because 1 is actually the parent node for this 0. From there only the call basically started, right, all the way. For 5 also we did the same, like I am not interested to explore this 2 because it is the parent. For 2 0 is actually its parent, so we already consider that for 2 we explored all the nodes, so we don't have any options to further. Then only we tried putting a cut right over there and we tried generating the answer. Okay, now from 2 we reach back to this 0 because we explore all the node. From 0 again we don't left with any other further options where we can go and explore their nodes. Okay, so whatever the previous values or that we got it so far, that is something what we will put it right over here as well. So for 4 again what we do is like 4 or 3 or 7, that is something what it returns back at this particular location. Okay, so what we do is simply we will put a cut right over here for this 0 because parent and child, between the parent and child only we will be having these cuts. Okay, so for 0 the parent is basically 1, so there is something what, there is where we are putting the cut because for 0 we explored all the possibilities. Now the next cut is going to be there right over there. Okay, so once we put this cut, it is like this way. Okay, this is one individual component, this is another component, this is the third component. This component's value is already with us. Now this component's value is like, since we are backtracking, so 4 is whatever the 4 value and previously value that we have XOR value, with that one only we are performing this operation. So for this particular area we got the XOR operation values like 3 XOR 7 XOR 4 because 3 is here, 7 4, these are the values that we have, right? So that operation value is cut 2, cut 1 is already there. So cut 3 is basically whatever these values when we simply do XOR operation with the total, it will simply cancel out all the left out values. So left out values are like 4 or 1. So that is going to be the cut 3. Correct. Again, we will perform the same operation and minimum value something what we will take out. Okay. So once that is done, the call reaches right over here. The call reaches right over here at this one. The moment we see that this one is from where we started, because from this node only we started exploring all the possibilities, right? So we don't have left out with any other possibilities to put the cut. The moment we reach at this one from where we actually started, we are done. Okay, so we will simply make a note right from where we started. The moment we reach to that particular node, we are done. We tried exploring all the possibilities, so we are not further going to perform the same operation. Okay, so this way it is basically gives us clarity that from where we started we reach to that particular node again. From one, I don't have any other options to go and check if I can perform the same operation, so we are done. We will simply uh, break out of that particular DFS false. Okay, so we will simply return from that DFS. Okay, this way we explore this particular possibility by putting a cut right over here. We explore all the possibilities that we can get it. Okay, the moment this is done, again we are back to the previous DFS, first DFS. This all the operations that we tried out putting different places cuts, that was the second DFS that we have seen. Now again we have to go into the first DFS. Once the second DFS operation is done, like we tried putting like all these places, like first cut was here, the second cut was here, okay, third cut was here, the next last cut was here. After this we are done, like we cannot further put any other cuts with this particular one cut. We tried out exploring all the nodes. So now again, once this is done, the call goes right over here at this location. While backtracking here also, what we do is again we will perform a XOR operation with this one. So previously here it was a 5 value, so here 5 XOR 5 is basically 0. So 0 is something what we will store. So again in the first DFS also we will do the same operation. While backtracking we will simply perform the XOR operation. Why we are doing this particular operation means we already performed a cut right over here. We already perform a cut right over here. Now next cut can be right over here or right over here. I don't want to go again and explore this particular cut. Okay, so if I am putting a cut right over here, this could be one answer. Okay, so this could be again when I try to put a cut, so this is going to be there like this. With this one, this whatever this three values there, it is going to be attached at any point in time, because I don't want to make cut right over here at this location. That is something what we already done. That is something what we have already performed. Okay, so yes, that is the whole idea. Like I mean, I explained it in different way right now, but yes, so what we are doing is like whatever the XOR operation that we are getting it from here, that is something what we have stored at this particular location, at this one, while backtracking. Now for the one, again we have this particular operation where we can go. Again we have this particular option where we can go. So what we will do is, again we reach at this particular one. Here we don't have any further options to explore. So what we do is like this is the last node that we have. So here we will put a cut. So previously we tried out with this particular one. Okay, because that was the last node where we can reach. Now we put cut right over here at this particular location. Okay, so once we put this cut at this location, what we do is we again do the same operations, right? So its parent is basically one. Its parent is basically one. So we go to that parent, and from there we will try to put all the different cuts. So again, sorry for this particular one also, it is going to be, this call is going to be make sure that here is first cut that is going to be happen. So definitely it will try to generate the same possible answers again and again for some of the cases. Okay, there could be a repetitive things also happening. So we are not tracing out those things like when we put first cut and here cut, what was the answer that we got it. So that is something what we are not concerning at this particular question, because maximum all these different possibilities that we are generating is, it is going to be all the way to n square. Okay, because for the first here is something what I have put, and these are the left out all different cuts that we have. For 4 also, here is something what first cut I have done, and these are the left out cuts that we have. Next is like here is something what I have put a cut. So this is one component, and this here are the different components where I can put the cut. This way, like I'm getting different answers, and all these different possibilities are going to be n square only. Like first DFS call explores all the nodes, second DFS call may be exploring all the nodes. It goes, in the worst case, it goes all the way to n. So n square is the complexity that we are getting it, and it is completely fine based on the constraint that we are having. So we are not actually trying to store their answers. Okay, for 4 also we will be doing the same. Like first cut is going to be here, the XOR value for the cut one is basically 1. Okay, XOR value again it going to be same. For XOR value it is going to be 1. Now here is something what I put the cut. So again I go to the parent node from where we came, like from one only we came. So we go there and we keep on trying to put the cut. So for one x we will be exploring this is the first part where we are exploring. So here is something what we are putting the cut. Again it is going to be the same answer like what we got it in a previous time, but here the cut 1 cut 2 are different. So okay, so cut 1 was here and cut 2 is basically 5. 5 is the answer that we are getting it right over here. So cut 2 is basically 5. because that is the last node that we have, right? From here we cannot explore further nodes. The same operation I'm doing it right over here. So once I get these two cuts, here is one cut, here is the second cut, this left out elements that are there, okay, this can be achieved with this total XOR minus this cut 1 minus cut 1 XOR, cut 2 XOR, this total XOR. When we do it, cut 3 XOR is also we can easily achieve it. Okay, this way we are done. So this way, once this is done, we are again going back from 1, we can explore this node, and again we will go right over here. 5 is here, first cut is there, again second cut is right over here, third cut is going to be right over here. The moment we explore all the nodes for this one, the parent node from where we are started exploring, we are done, we will simply return back. Okay, this way, like 4 is also explored. Okay, now once 4 is explored, same things will happen. Okay, I'm not going to explain again the same things, but now the moment we are at this 4, from this 4, it returns 1 as a XOR value. Okay, previously what was this value for 1? Okay, this was happening in the first DFS call. Okay, so previously the 5 was written from here, and it got XORed with whatever the 1 value. For 1 the value was 5. Okay, here it was 5, here it was 5. So 5 or 5 was the answer that we stored in the first DFS. This is happening in the first DFS, it is happening. Okay, now from here 1 is something what it returns. So again 1 is something what we are doing it. 5 or 1 or 5, that is the operation that we are doing it. Okay, why we are doing it, that is something I'll explain you now, right at this location. This, all these operations are happening in the first DFS call. Okay, the second DFS call we only do the moment we realize that we explore all the nodes for any particular component. Okay, for 4 we saw that we explore, sorry, for this 4 we saw that we explored all the components, there is no further going edges. For 3 also we noticed that there is no further going edges. Now for 1 we explore all its adjacent nodes. Okay, we explore all its adjacent nodes going down, but there is another, this is also a node that is there, but this is actually a parent node from where we started, right? In the first DFS call I already said that from 0 we started. Okay, from 0 we have started. So here I cannot consider this as a my parent node. Okay, this is a parent child relation from 0 to 1, because from 0 only we reach to this 1. So this is not adjacent node for this one, it is a parent's node. Okay, so the child nodes we explored for this one, so I have to consider that I have to put the first cut right over here now. Okay, we put the first cut here, second time we tried cut here, and we called a DFS. Now we have to put cut right over here, and we have to call a DFS. The operation is pretty much straightforward, right? Like what we are doing now. Now I already got a cut here, so I don't want to go and in this child, and I want to put the cuts right over those locations. Okay, so to avoid those duplication, what I have done is I already calculated the XOR operation while backtracking. Like we are done from here, we backtracked and we XOR operation with this one. Here also we XOR operation with this one. Okay, so this way, like I don't want to explore their children's again. Okay, so I am putting a cut right over here at this particular location. Okay, I am putting a cut right at this location, because for 1 we explored all its nodes. So this is like the first cut that we are putting it, and its parent node is this one. 0 is the parent node, 0 is the parent node, right? So that is how we are doing it. So I have to get these values XOR also at this particular one. Okay, because I cannot again go in this particular one and recalculate what are XOR values in this particular area. So while backtracking only, I am storing their values. So 5 XOR 5 XOR 1, these values I have already stored right over here. While backtracking, we are performing this particular operation. Okay, in this first DFS. Now the first cut is like for this one we are putting a cut right over here. This is like individual component, and this answer for this individual component is already we have calculated. It was like 5 XOR 5 XOR 5. Okay, while putting the cut right over here at this one. Okay, once we are done this one, what we do is from 0 we will try to explore in this second DFS call. In the second DFS call we will perform the same operation. From 0 we are trying to explore. So this is one individual component. Now I have for 0 I cannot go back from where we came, right? Like in the second DFS we have to make sure that like the area where we have put the cut, we are not going to call in that one. Okay, because that has been broken down. So from 0 I have to go in other edges where we can go possibly. Okay, so this is one edge that we have. So we start calling the DFS again. We reach to the 2. From 2 we have only one option, that is like 5 where we can go. So the moment we reach to the 5, we will put cut right over here, because from 5 we don't have any further nodes where we can go. So the cut is going to be right at this location. So how this works, like this is one component, this is second component, and this is the third component. For this individual component, the XOR value is going to be the same. For 5 the value was 7. 7 is the value that we have. So that is the cut to XOR value that we got it. So same operation we are doing it, right? Like I'm just simply explaining on individual nodes where we are going back. Okay. So 7 is the value that we have at this particular one. So 7 is the cut to value that we got it. Okay. So here is the second cut that we have put. So cut 3 is basically going to be this one, like 0 and 2. So to get that, like same operation we do, cut 1, XOR, cut 2, XOR, total cut. Okay. This way we will get cut 3 value as well. Like this is the cut 3 that is going to be there, right? Like the moment we cut this one, cut this as a second one, we are done. Okay. Now the answer, something what we get it. So again, we will do the backtrack in the DFS, second DFS. Once we are reaching at this one, we are performing the same operation, 3 or 7. While backtracking, we will do this operation. So for 2, we are done. We cannot have any further nodes where we can go. 0 is the parent node. 5 is where we have explored already. So 2 is already done. So for here, we will put the second cut. Okay. The moment we realize like we don't have any further nodes where we can go, we will put the second cut right over here. So this way, like this is another component, this is another component, and this is the last one. Right. So same operation happens, like cut 1, cut 2, cut 3 values, we will easily get it. The moment this is done, like we will be backtrack to the 0. Now the moment we reach to the same index where we have already put a cut, we are done. We cannot explore further, we cannot put any cuts apart from these locations. Okay. And I already make sure that like from 0 I don't want to calculate these values, like what are the cuts for this one. So while backtracking only I have stored these values. Okay. Once this is done, we reach to this 0th node. Okay. We reach to the 0th node. Okay. Once the cut is done at this location. Okay. So we are simply trying out all the different possibilities, right? Like where we can put the cuts and how we can get answers. For 0, once we back, we have still, there are nodes which are necessary to explore. So for this 0, the values are basically like, let me just clean this up. Okay. So let me name it as like cut 1, cut 2, and cut 3. Okay. So from 1, once we are backtracking, what happens is like whatever the totals are that we got it, that is something what it stores, like total zeros, like 5 or 5 or 1 or 4, add is 0. This is the value it basically stores. Okay. From 0 further, like I cannot go here because that is something what we already explored so far. Okay. And now we have this option, this is happening again in the first DFS call. Okay. The moment we get the answers from the cut all the cuts, we are simply going back into the first DFS calls. Okay. From 0 we are going back to this 2, from 2 we are going back to this 5. Okay. Now the moment we reach to the 5, what happens is like again we are putting a cut right over here, because from 5 we are not going, we are not having any further options to go. The moment we put a cut, we again go back to this 2 and we will doing the same option, like what we have done for this 1 regarding this 3, same operation happens again in this particular direction. Okay. That is how it basically works. The moment this is done, like again this callbacks to this 2. From here to, I'll put a cut right over here. While backtracking, I'll perform this operation like 3 or 7, and that is something what I'll be having, so that I can have this option to put a cut right over here. And again we will go and we will try to put some different places cut, and we will try to generate the answer. This way we will try to explore all the different possibilities and we will easily collect the answer. I guess this idea is pretty much clear what I have tried explaining you. Now let us try to write down the code. While writing the code also, I'll explain you like what is happening and where we are doing these operations. Okay. Just stay tuned. Okay. So focus on this particular screen. I'll write down the code, how to write that algorithm. Okay. The first thing that I'll do is I'll get the how many elements that are there. So nums dot length, these many elements that we have. So here in inputs we have given its array list. Okay, which basically tells like there is an edge between 0 to 1 and 1 to 0. So I'll try to convert this into the RSNC list. So that is the bare minimum thing, like you guys should have idea before solving these questions. Okay. So I'll create a RSNC list right over here. And in this RSNC list, what I'll do is let me fill this one. Int I equals to 0, I less than this n, I plus plus. Let us fill all this list with array list dot add new array list. Okay. Now from this edge array, int edges, we have to put this one, right? Like for list dot get this edge of 0, we have to add this edge of 1, vice versa, like list dot get because it is an undirected graph. So if there is an edge between 0 to 1, there should be edge between 1 to 0 as well. So edge of 0. This way I have created the RSNC list. Now here currently in the edge list, like there is a graph, there is an edge between 0 to 1, 1 to 0. So I have created this RSNC list. This will tells like for 0, how many edges are there. For 0 there is like 1, that is going to be 1. For 1 it is having, these are the edges that we have. Like for 1, the first edge is between like 0 to 1, that was there, so 1 to 0 is going to be there. Then it is like 3, and last one is like 2. Okay, this way we are actually creating this adjacency list. For 2 also, like there is an edge between 1 to 2. Okay, this way I have created it so that I can easily explore these adjacent nodes. Okay, once we are done with this adjacency list, I have to calculate the total XOR value. So what I'll do is I'll create a variable total XOR. Initially it's 0. So let us start with this nums array, int num, because based on this nums array only, whatever the values that are there, we are calculating the XORs, right? So from this one, let us calculate the total XOR. So total XOR, we will put this XOR operation here with this num. So this way we will get the total XOR, and this will be helpful for cut 3. Okay, so cut 1, cut 2, we already got their XOR values. So cut 3, if you want to get it, so total XOR with whatever the cut 1 XOR, cut 2 XOR, when we do it, the cut 3 XOR is something what we will be getting it. Okay, once we are done with this, the next goal is like we will simply call a DFS. So we will start with 0. We can start with any particular node. There is no compulsion that we will start with the 0th node, but here I'll start with the 0 because 0 is definitely going to be available. I am not sure like which is the last element in between. It is fine to start with the 0. Okay, so for 0, I am not sure like what is the parent. So I'll initially, because I have started with 0, so I'll name it as a -1 as a parent, because we are keep tracking like what is the parent node for this one, from where we have came at this particular node. Okay, this way we will not again go and revisit the same node from where we came. Okay, that is the bare minimum thing that we have to follow whenever there is an adjacency. I mean, when there is an undirected graph is given and we are trying to call the DFS. Okay, so we don't want to recall the previous parent node. Okay, now once this is done, next is like total XOR value is something what I'll pass right over here. Nums array is something what I'll pass it. What is left, like n value also we will pass it. Okay, it is not necessary as well, but okay, fine. Let's see how it goes. Now I'll create a void DFS this function. So instead of void, what I'm doing is like I'm performing the XOR operation, right? So I will maintain here it as an integer. So this is like the index at which we are at, current index. This is the parent node that from where we are coming. Okay, initially for 0 the parent is -1. We are not sure like what is the parent for this one. Okay, now total XOR. So here it is like total is something what I'll name it. Okay, so you will consider that total XOR is basically total, cut 1 is basically cut XOR 1, cut 2 is basically cut XOR 2. Okay, so now here it is ints num, last is like total nums that we have. I don't think this n value is necessary right over here. Just let us remove this particular one. Now the first thing is like the DFS call is happening, right? So what we will do is here I'll create a cut 1. Okay, cut 1 is something what I'll create it, cut 1 XOR. That is the thing that I'm creating. That is like last index. When we are calling from this 1, the call goes to 3, call goes to 4, and from 4 I cannot go further. So like for last index, the XOR value is going to be the same one, whatever the nums value. So whatever the nums of index that we have, that is the cut 1, that is going to be there. Okay, so last index, the moment we reach to the last element from where we cannot go further, so the XOR value is going to be the same that nums of IDX that is there. So that is the cut 1 that we have. Okay, while backtracking, we are simply updating this cut 1 that we are having. Okay, now cut 1 is something what I got it. So I'll try to explain the adjacent nodes. Okay, ADJ, whatever the adjacent nodes that we have for this list is something what I have to pass right over here. So list is also I'll pass in this one. Or what we do is we'll put this list outside so that I am not making these calls every time while making this function. So I'll put this outside right over here. Okay, and list is something what we have initialized. So yes, that will avoid like I just don't want to rewrite here. So in this list, I'll try to explore the adjacent nodes for this particular current index. So if we are current index is 1, so their adjacent index are like 3, 0, 2. These are the adjacent nodes that we have. Okay, so I'm trying to explore all the adjacent nodes for this current index for this 0. Okay, so now once we start exploring it, the first thing is like whatever the previous XOR value that we are getting it for this particular DFS, we will simply perform the XOR operation with this cut 1. So cut 1 XOR equals to whatever the DFS cost that we are doing it. So the moment we reach to the last node, like fourth one, we try to put a cut with the second DFS and we are done. We are getting the answers. So now this 4 is something what we are returning back. Okay, from 4 we are returning back to the parent node. While returning back, it will reach to the this DFS only. So while returning back, I'll make sure to return this value, nums of I value. Okay, so that while backtracking, we will simply XOR with the current node. Okay, that is the operation. So this is like for the backtracking, I am keep on tracing like what was the previous XOR value that we have, and that is something what we will keep on maintaining it, so that next time when I put the cut, I don't want to recalculate what was the XOR value for this 3 where I am putting the cut. Okay, this is how it keep on tracking. This is how we can keep on tracking. So artisan is something what I'm passing right over here. The parent is going to be this index from where we started. Okay, this is how parent is basically get updated. Total is going to be the same one. Total is going to be total, and nums is going to be the same one. Okay, but here we have to make sure that when we reach to the last index 4 4, I don't want to again go and revisit to this 3, because 3 was the parent for this 4. So we will check that if this arson is basically equals to this parent from where we came, so we will simply continue. Okay, because for 4 the arson value is 3, that is the only value that we have, and it is actually parent. From 3 only we reach to this 4. Okay, in this first example I am talking all these particular things. From 3 only I reach to this 4. Okay, so I have to make sure that this arson, because for the 4 arson is going to be 3, so I have to make sure that this 3 is again, I'm not revisiting to this 3. So that's why I am making this if condition, I am continuing from there. Okay, the moment this is done, the like this index is when we reach to the last node, we have to make a call as a second DFS, because I want to put a cut right over there. So when we reach to the last one, by calling the DFS, it will keep on calling from 1 we started, we reach to the 3, from 3 we reach to the 4. Okay, the moment we reach to the 4, we cannot enter into this one because we continued it. So we explore all the nodes, arson nodes for this 4. That is how it basically says, because 3 is where we are not reaching out, we are simply continuing, and we don't have any further cuts to call the DFS. Okay, we are done. That is the only arson element that is available for this 4. So we are done. So from 4 we are done. So this for loop is basically done for the 4. What we do is basically we'll try to calculate the cut. Okay, so for 4, like we are putting a first cut right over there, and we'll try to generate the answer. So what we will do is, again we will run a for loop. So for here, like again for this particular 4, there are adds and nodes, so I'm just naming same things, like here also adds and here also adds, and like it is, just don't confuse with these names, because for 4 also we can have multiple adds and nodes. We can have multiple adds and nodes, like for 1 we have multiple adds and nodes. The moment we reach this callback from here, the moment we reach to this one, again we have multiple addition nodes, but we have to make sure that we are putting a cut between the child and parent node, because I don't want to make cuts again further going downside. Okay, so for this addition node, the 0 was the child node, because from 0 only we all the way started. So I have to put a cut between this 0 and 1. In the parent and child only I am putting this cut. So what we will do is, like we'll start again going through this addition nodes of this list for this particular current index, that is where we are at. Okay, and here what we do is, whatever the arson values that we are getting it, we check that if this arson value is basically equals to the parent value that we have. Okay, in that case only I am putting the cut. Okay, so the second DFS call basically happens in that case only. Okay, so let us focus right over here what I am trying to do. Let us say that from 0 we started. Okay, from 0 we started, we reach to the 1, from 1 we reach to the 3. Now from 3 I cannot explore further. Okay, I cannot explore further, because 1 is the parent. 1 is the parent, we cannot explore. So this for loop is done. For loop is done for that one, for 3. Okay, now for loop is done, so we have to make sure that for this particular 3, what are the arson nodes that we have, we will again go through it. And the parent node from where we came, there is something what I want to put the cut. Parent node where from where we came, there is the cut that I want to put. So that is the same thing I am doing it. I am exploring the arson nodes for this last index where we reach, and I'm checking that the moment we see that this arson node is actually the parent node from where we came, so I'm making this DFS call, so that the first cut is something we are putting at that particular location. So in this second DFS, what I pass is, like first is like the index, current index. Okay, then this arson from where we are keep on calling, so this arson is going to be the index for next one. Okay, that is the index. And next is like this, let me pass this idx as well, because I don't want to go on this particular idx. Okay, idx is going to be the parent now, because the reverse DFS is something what we are calling. Okay, for this one, here is something what I have put a cut. Okay, and from here I want to explore again the DFS, and I want to put all the different locations the cuts. Okay, I want to put the cuts from all the locations. So this one is basically representing as the arson node. Okay, from where we are again calling the DFS, second DFS. This IDX is basically where I don't want to go. IDX is where I don't want to go. And again, there is this parent node. Like again, the moment we perform all the operations, like from one, I explore zero, all these different nodes, and I reach back to this one. So that is like again, this one is basically representing as adjacent. So that is something what I again passing it. So the moment we reach to that one, exploring all the different paths, we will simply return back from this particular DFS. Okay, that's why I have passed this adjacent value as well. Okay, so these three values I have passed. Then this cut one is something what I also pass. Total is also I will pass. Okay, that way we, the moment we get in the second DFS the cut two, we will simply perform that operation, cut one, cut two, cut three, this total. This way we will get a cut three when we perform this operation between this cut one, cut two, and total. Okay, these two values I have passed. Next is like this nums. Okay, I think that's all. Like I don't need any further values, okay, to pass right over here. So the second DFS function I'll write down here, int DFS2. In this one, the first value is like this arson. So it is like the index from where I have started exploring. Okay, now just don't confuse with these values with these values. Okay, because this is like how I naming and put their names. This arson is going to be the index from where I'm starting out. Okay, and this index that we have, this idx, is going to be the node, the parent node, because I don't want to revisit to the parent node, because the moment we reach to this 3, now we are performing a cut right over here. So for this one, it is going to the parent where I don't want to go, because here is the cut that we have put it. Okay, so we can name differently as well, but again, like it is a parent node where I don't want to reach, so this is going to the parent node where I don't want to reach. Okay, that's how we can name it. Now next is like the ancestor where we reach back, because from one only we started. Okay, from one only we started, right? From here only we started. So we explored all the different possibilities, and the moment we reach back to this one, I don't have any options left out. So the moment the ancestor equals to this idx, we will simply return. So that's why this ancestor is something what I'll name it right over here. Now next is like the cut one, next is like the total, and last is like these nums. Okay, so what we do is again here in this one, I'll name it as a cut to. We are simply calling the DFS the same operations. For this cut to, the last index, once we reach, the same value is going to be there. So nums of this IDX where we reach, I'll run another for loop here. The IDX is going to the arson nodes ADJ. For this list dot get index, for this index from where we are started exploring, like for this one, this is the IDX for us, and its arson nodes are like these are the arson nodes where we are again running this for loop, and we are calling the DFS. Okay, so simply here also I'll do the same operations, like cut to XOR equals. Again, I am while coming back from this one, while callback is happening, backtracking is happening, basically I am simply adding these XOR values as well. So that way, like we don't want to pre-compute again for cut to where we are putting the cut to. I don't want to make sure like again go into that particular cut to and calculate the cut to XOR values. Okay, so while simply backtracking, we will calculate these values as well, the XOR values. Okay, this way we'll get the XOR values. So DFS2 is something what I'll call it, and here the IDX is going to be this arson node. Okay, parent is going to be this IDX. Ancestor is going to be the same throughout this journey. The last one is like cut one is going to be the same one. The total is going to be the same one, and nums2 is also same. Okay, this way we got right over here. Cut 2 is something what we got it. The moment we reach to the last one, there is something what the first cut going to be there, right? So now cut 2 is also we got it. Like let us suppose the DFS is something what we are calling it. From this one, we reach to this last. Here we don't have any options left, so we are putting a cut right over here. So again, that is the cut to. This value is going to be available. 7 is available in this cut to. Okay, because for this one we are not entering into this while loop, for loop. So here also we will make sure that from parent node where we came, this addition is not going to be the same node. So this whatever the addition, if it is equals to this parent node from where we came, we will simply continue. Okay, this particular if condition says that, like from 2 I reach to this 5, the DFS call. From 5 I cannot further go, like 2 is the parent node where I don't want to go. Okay, because that is how we are storing these values, right? Like from 2 the DFS call goes to the 5. For 5 its parent node is 2. So from 5 I don't have any further nodes, and there is only a node that is there, but that is the parent node, so where I don't want to go. So this condition basically makes sure that we are not going again back to the parent node. Okay, so this for loop, once it is done for the last node, we have to perform that operation. What operations? We will calculate the cut 3. Int cut 3 equals to, okay, this total XOR cut 1 XOR what was this cut 2. Okay, cut 2 is there, right? So we got all the different cuts XOR values, total individual cuts, whatever wherever we are doing it, all their XOR values are something what we got it so far right over here. Now the only option is like we will create a global variable where we keep tracking the values. So int global is something what let is like minimum answer is something what we are calculating, right? So initially I'll fill it with this integer dot max value, that is the value that I am filling out inside here. So mean answer is something what I am keep on updating it. So mean answer equals to, let us create here math dot mean between this mean answer so far, if any previously if we got it, or else I'll create here a calculation function calc where I'll pass this cut 1 cut 2 cut 3. Okay, and out of this maximum and minimum values I have to figure out, and there I have to generate the answer. So I'll create this calc name function right over here, int calc. Here is like x1 is going to the first cut, int x2 is going to be the second cut, third cut is going to be x3. Okay, so now we have to pick out the maximum value and the minimum value, and we have to simply subtract. So what I'll do is like I'll get the max, mean math dot max between this x1, math dot max between this x2 and x3 minus, okay, this is like minus math, sorry, math dot mean between again x1, math dot mean between this x2 x3. Okay, this way easily we can get the answer. Here it should be m capital. I guess all the brackets are correct. We have, yeah, it is I think correct. So this way we'll get the maximum value from here. It should be max, right? Why I have mentioned here mean, it should be max between all these x1 x2 x3, max mean between x2 x1 x3. We are simply subtracting and we are returning it. So this way the calculation basically returns the minimum subtraction. So far we got it and we are updating it. The moment we calculate it, we'll simply return this cut 3. Okay, this way like cut 3, the moment cut 3 is basically written back, right? Or sorry, it is not a cut 3, it should be cut 2. Cut 2 is something what we are returning back. So here in this DFS2, the parent node is where we reach, and there we are simply putting this cut 2 as XOR operation with this cut 2. Okay, I guess this operation whatever we are doing it should be clear to you all guys. And we have to make sure that we are breaking out from here as well. The moment if this ancestor, if it is equals to lastly all the calls happens, whatever the adjacent nodes that we are having, the moment it is done, whatever the ancestor, if it is equals to this idx, we will simply return this cut to as well. I mean, it is not necessary to return and all, but since it is requiring this integer value, so we are returning this cut to. Doesn't matter, we are not going further ahead from that. Okay, this way we can easily calculate these answers. So now that's all, like the moment this is done, like for here also, like we have to return this cut 1. Once we calculate the DFS2, we have to return this cut 1 back, so that at this particular location from the previous function, it will return the whatever the previous XOR value that we have to the parent node. Okay, this way we will keep on doing this operation. Now let me try to run this code and see. Now we have to return here as well, return this mean answer, and it should be int only, it is not an integer array. Okay, let us see if we have any issues or errors. It is getting accepted. Let me try to submit this code and see if it is working fine or not. It is working fine. Okay, so yes, this is how we can solve this. And I already explained like how the time complexity works. Like we are trying to explore all the different nodes. From here we reach to this particular node. Let us suppose in the first EFS call is like we are simply exploring all the nodes, right? Okay, and we are keep tracking like what is the parent node, so that we are not revisiting that node. The moment we reach to this one, again we are calling the second DFS. So second DFS again try to explore all the different nodes that are available. So this way, like for each individual node, we are performing the same operation. So in worst case, it goes all the way to n square. Okay, that is the time complexity. Space complexity is basically, again we are just trying to create this adjacency list which holds n elements. Okay, so this adjacency list is something what we have created. So it is going to be n, and this call stack is also like whatever the DFS call stack that we have, it is going to be big O of n cross n. Okay, so this way we are performing these operations, and I hope you get this idea like what we have done in this particular one. If so, please make sure to like this video, and thank you for watching this particular video. Bye bye.